This is a very short introduction to working with matrices in Matlab. First, let's look at row vectors. You create a row vector by using these square parentheses like this, and then you can just put all the numbers that you want in your row vector. For example, 2, 3, -1. End it like that, and that will create a 1 by 3 row vector with these elements. If you want to retrieve the last input you typed, you can use the up arrow key like this. And then we can see that you can also, if you like, add commas between them. That makes no difference. So this will be the same thing. It will be the same 1 by 3 row vector. To do column vectors, you also use square parentheses, but in this case, you separate the elements using a semicolon. So 2, 3, -1 separated using a semicolon will make this into a 3 by 1 column vector instead. If you would like to save any result, you can assign it to a variable by typing, for example, a equal to, and then if we want to create a row vector, 2, 3, -1, and that will save this row vector into the variable a. You can check this in a couple of ways. You can see that you have the a over here, 2, 3, -1, but you can also print the content of a in the command window by just typing a. Notice that when we did this assignment, Matlab also printed the result. If you want to, you can create a silent assignment of a. So if I do instead a equal to 2, 3, -1, and I end that with a semicolon, then the assignment will be made, but Matlab will not print anything. Next, we have the concept of concatenation. So let's define a as a new row vector. Let's just do, let's say 2 and 3. So it'll just be a 1 by 2 row vector, silent. If I do this, it will just overwrite the previous definition of a. So that's my a, and I'll define a b as another 1 by 2 row vector. Let's say -1 and 1. So I can now concatenate these two row vectors a and b. I can do that in two ways. I can put a, and then to the left of that I can put b, or vice versa. Or I can put them above each other. So I can put a above b. To put them arrange them horizontally, you do sort of a similar thing as you did with the numbers. So I can just put an a here and a b here. That will put a and then followed by b, so that will be a 1 by 4 row vector like this. If you want to put them, arrange them vertically, you can do a semicolon b. That will put a above b, so that will then create a 2 by 2 matrix where a is the first row and b is the second. So you can use this trick of concatenation to create a matrix in just one step. So if I do parentheses, parentheses, and I put my first row here, let's say 2 and 3, and then I can concatenate that with the second row, let's say -1 and 2. That will then directly create a 2 by 2 matrix where the first row is 2, 3 and the second row is -1, 2. Now in this case, the inner parentheses are optional, so I can actually remove the inner parentheses. Matlab will understand that exactly what this means. It understands that this should be a 2 by 2 matrix with 2 and 3 in the first row, minus 1 and 2 in the second row. So that will give us this exactly the same thing. You can easily create the identity matrix. Let's say you want a 4 by 4 identity matrix. Then you do I for identity matrix and you just do 4 like that. That will give me a 4 by 4 matrix where the diagonal has ones and you have zeros outside that. You can create matrices which are filled with zeros or with ones. So if you do zeros, for example, then you can create an arbitrary matrix, let's say 5 by 3. I'll give you a matrix with 5 rows and 3 columns filled with zeros. Or you can do a matrix filled with ones. Let's say 5 by 3. Create a matrix 5 by 3 where every element is 1. Next, let's look at how to pull out subsets of a matrix. So let's create a simple matrix. A is something 2 minus 1 for the first row, and let's say 0 minus 2 for the second one. If I want to pull out an individual element and do something with that, I can do that by typing simply A parenthesis. Then I need to select the row number. Let's say I want the first row, comma, and select the column number. Let's say second column. So this will pull out the element of A in row 1, column 2, which is minus 1. So this will return minus 1 to me. You can also pull out an entire row of a matrix. And to do that, you do A. And let's say I want the first row, the one which has 2 and minus 1. So I'll do the first row. And then basically I want all the columns. And all the columns, or all in Matlab, is the colon. So 1 comma colon will give me the first row, all columns. So that will be 2 and minus 1. I can pull out an entire column in exactly the same way. So if I do A, and now I want all the rows and a specific column. So I want all the rows, and then I can do 1 or 2 depending on which column I want. Let's say I want the second column. So that should now return the second column, which is minus 1, minus 2. You can also pull the diagonal of a matrix to remind us what A is. If you do diag of A, it's going to return a column vector containing all the diagonal elements, so 2 and minus 2 in our case. And you can go the other way, so you can create a diagonal matrix using the diag command. So if you do diag, and instead of feeding a matrix, you feed it a vector. So let's say I'm feeding it this vector, 2, 3, minus 2. Then it will create a 3 by 3 matrix because I fed a 1 by 3 row vector, and 2, 3, minus 2 will be the diagonal elements. And it'll fill, of course, then the rest with zeros, so that will be the result. Next, a useful concept is the concept of a sequence. So if I do, for example, 4 and colon, and let's say something like 9, that will create a sequence starting at 4, ending at 9. And this sequence will be put into a row vector. So starting at 4, 5, 6, 7, 8, and 9. If you want to put it into a column vector, just check the transpose below. There is a second version of the sequence operator which you use if you want the increments to be something else than 1. So if you do something like, I don't know, starting at 6, and let's say you want to increment by 2 each step, then you do 2, and then where it should end, maybe at 14. So that will give you then 6. Next one will be 8, 10, and so on all the way to 14. So we know how to pull a single column and a single row from a matrix. Sometimes you need to pull several rows and columns from a matrix. So I'm just going to create a simple matrix. Let's say the identity matrix. Make it 5 by 5. Remember, if I want to pull, for example, the first column, I'll do this. All rows, first column, and that will give me the first column. But if I want to pull several columns, or let's start with several rows, I can do something like this. A, parenthesis, then I just put all the rows that I want into a row vector. So let's say I want to pull row 1, 3, and 5 from the A matrix. I can do that followed by a colon to signify that I want all the columns. So row 1, 3, and 5, all columns, and that will give me exactly this. Of course, I can do the same thing selecting columns. So if I do A, all the rows, and I want columns, let's say 1, 2, and 5. That will give me these 3 columns. You can also combine them. So let's say I want the first and the third row, and I also want the first and the third column. So that will pull the first and the third row, first and the third column. So that will be a 2 by 2 matrix looking like this. If the matrix is large and you want to pull several columns, then you can also use the sequence operator to do that. So let's say I want to pull all the rows from, let's say, 2 to 4. Then I can do the sequence operator. All the rows from 2 to 4 and all columns. So it will give me rows 2, 3, and 4 like that. If you have a matrix and you want to make some edit to that, you can also do that. Let's look at A again, for example. Let's say I want to put a -1 in position 1, 2. First row, second column, I want to put a -1. Then you just assign that 1, 2, and you set equal to -1. That will put a -1 in that position. Using the same technique, you can replace an entire row or column of A. So if I want to replace the entire first row of A, so first row, all columns, I can just set that to then an arbitrary row vector. Let's say I want to replace that with 1, -1, 1, -1, and 1. Then I get that row into the first row of A. Similarly, if I had done instead column, 1, it would replace the first column of A with this 1, -1, 1, -1, 1. Actually, as you can see, the first column is obviously a column vector, and on the right hand side it's a row vector, but Excel doesn't really care about that. It understands what we means, and it will put that into the first column. Sometimes you just want an arbitrary matrix to work with, just to, for example, test some formula that you have. Then you can use the rand function. So if you do rand, I will create a matrix where all the elements are drawn from the uniform distribution between 0 and 1. So let's say 6, 3. Give me a 6 by 3 matrix where each element is a drawing from the uniform. If you prefer random numbers from the normal distribution, you can just replace, you just add an n to it, rand n. Then each element will be drawn from the standard normal like that. There is a sum function. So for example, if I create a column vector rand of, let's say, normal numbers, 10 by 1, so it'll be a column vector with 10 rows, then I can sum all these elements by just typing sum of A, and we'll sum these elements minus 1.37. And the sum will work also if A is a row vector. And the thing to note is that if you do the sum on a matrix, so let's say I do A equal to rand 3 by 3 by 3 matrix, and I do sum of A, what it's going to do is it will sum column by column. So the result will be a 1 by 3 row vector, where the first element, 1.8013, is the sum of all the elements in the first column of A. If you want to sum by row, then just have a look at the transpose function. We can do some basic algebra. So I have my A, and let's create a B as well, making it 3 by 3 rand 3 by 3. So I have two matrices which have the same dimension. Then I can add them by just using the plus sign like that, A plus B, and it will then of course add these two element by element. To do addition, the dimension must be the same. So if I do something like C is rand and just 2 rows and 3 columns, then if you try to do A plus C, these A and C do not have the same dimensions. It's gonna say that that's an error. So remind us ourselves of A. You can do a scalar multiplied by a matrix. So for example, if I want to do minus 2 times A, that will multiply each element of the matrix A by minus 2. I'll get that one. And you can do matrix multiplication by just using the multiplication sign. In this case, A and B are both 3 by 3, so multiplication is allowed, and the product itself will be 3 by 3. And that's the answer. So you can play around with this and convince yourself, for example, that matrix multiplication is not commutative. This is A times B, but if I do B times A, you'll get a different result. Sometimes you actually want to do element by element multiplication, and you can do that in Matlab as well. So remind ourselves what A and B are. So my A and my B, and if I do A and a dot multiplied, dot in front of an operator typically means element by element in Matlab. So A dot multiplied by B will do A times B element by element. So 0.2221 in the answer in position 1, 1 is simply 0.4456 multiplied by 0.4984. To do transpose, you simply use the prime sign. So let's do a new A, which is not square. So let's say A is rand, and let's say it has 4 by 2. 4 rows, 2 columns. Then to get the transpose of A, you just do A and then the transpose sign. So that will be a 2 by 4. The first column has been switched into the first row and so on. We can also do the inverse. So let's say I have, let's look at B again, which is square. To do the inverse of B, we simply type inv parenthesis B. That will give us the inverse of B. Let's call it something C. Just confirm that it gives us the right answer. So that's the inverse of B. And if I try B times C, that should give me, by definition of the inverse, the identity matrix. And it does, as we can see. Similarly, C times B will also give me the identity matrix. If you try to do the inverse of a matrix that is not invertible, then you'll get an error message. Let's say, for example, I do just like this, 0 by 0. This is not invertible. Determinant is 0. So if I do inv of A, it's going to protest by saying it's singular. So this is one thing you can do is to play around with all the matrix algebra results that we have and just convince yourself that they are correct. So let's do another A. Let's say rand 3 by 3. And let's do a new B, rand 3 by 3. Then one result that we have, for example, is that if you do A times B and then take the transpose of that result, that should be the same thing as B transpose multiplied by A transpose. So we can check that. So this is A times B transpose. And if you do B transpose and you multiply that by A transpose, you should get exactly the same thing. And we can see that we do.